So children, today we discuss about three equations of motion in kinematics. That is motion in one dimension. So we are discussing motion in one dimension along with acceleration. Let us go for that. The first equation of motion is going to be v is equal to u plus at. Let us discuss about this. V is equal to u plus at now. So how are you going to discuss about this here? Let us imagine there is one vehicle whose initial velocity is 2 meter per second. After certain time t is equal to 4 seconds, let us imagine, its speed is going to increase. Okay, so previously its velocity was 2 meter per second. Now its velocity is going to be, let us imagine, 10 meters per second. It is moving very fastly with a speed of 10 meters per second here. Now let us see what happens. The time taken is this one. And we shall discuss about the first equation of motion here. You know, acceleration. Okay, so what do you mean by acceleration here? Acceleration is nothing but change in velocity with respect to time here, or increase in velocity with respect to time. You might have observed in a railway station, as soon as a train starts from a platform, slowly its velocity increases, and at certain time it is going to become maximum here. So increase in velocity of a train, let us take, slowly it increases its velocity, suddenly it doesn't take place here. So we shall discuss about this concept here. Acceleration is equal to, what is the formula here? Change in velocity by time taken. So change in velocity by time taken. So acceleration is equal to, change in means final minus initial, that is v minus u by t. So according to this problem you can write 10 minus 2 by 4. How much it is going to be? 8 by 4. That is acceleration will become 2 meter per second square. This is the basic formula for acceleration. But we need to find out what is the first equation of motion here. So how are you going to find out the first equation of motion? V minus u is equal to at here. From this you are getting this one. So v is equal to u plus at. So we got the first equation of motion here. So this is the first equation of motion now. So we shall discuss about what do you mean by second equation of motion. How are you going to find out the second equation of motion in this case? So let us imagine this is called as s is equal to ut plus half at square. This is called as second equation of motion. So we need to find out the second equation of motion. So how are you going to find out the second equation of motion in this case? Let us consider the same concept here. Let us consider a vehicle is there whose initial velocity is 2 meter per second. Slowly its velocity increases to the final velocity, that is 10 meter per second here. So time is going to be 4 seconds. Time is going to be 4 seconds here. Now let us find out what is the distance traveled by this car or what it may be. So let us imagine this is going to be the distance traveled here. So what you have to find out here, first thing is you need to find out what is called as average velocity. Average velocity means how are you going to find out? So average velocity is nothing but sum by number, you can say. So sum of the velocities by number of velocities. You can write sum of the velocities by number of velocities. Sum of the velocities means v plus u by 2 is called as average velocity. So I can write now here v plus u by 2. This is going to be the average velocity here. Now how are you going to find out displacement here? So let us take here average velocity is equal to total displacement by time here. So average velocity, another formula, this is the first formula, initial plus final by 2, but general formula for average velocity is velocity is equal to displacement by time here. So from this, displacement can be written as average velocity into time here. So what I am going to write here is displacement is equal to average velocity into time. So average velocity formula is v plus u by 2 into t here. Okay, this is going to be, let us imagine, equation number 2. Okay, so let us imagine this is going to be equation number 1 here. So in this case you are going to do substituting 1 in 2. Let us substitute this equation over here. Let us see what I am going to get now. So this one is s is equal to here, v means you are right, u plus at plus u by 2 into t here. Okay, so this is going to be the formula. Just substituting v value here, what are you going to get? Let us see. So s is equal to u plus u is 2u plus at whole divided by t into 2 into t here. So let me take multiply here about multiply t here also. You'll write 2ut plus at square whole divided by 2. Now you just partially divide these two terms. So you can write this as 2ut by 2 plus at square by 2. 2 gets cancelled. Finally you are getting s is equal to ut plus half at square. Okay. So this is going to be the second equation of motion we can write here. So let me write second equation of motion. This is going to be the second equation of motion here. Now let us discuss about the third equation of motion. That is v square minus u square is equal to 2as. So how are you going to get this third equation of motion here? For that, what we need to do? Let us take here one equation, that is acceleration. You know, we know that because already we have written here. So we know, okay, so acceleration is equal to v minus u by t. Then you can write v minus u is equal to at. Let us consider this is equation number 3 here. Next, one more equation is there, that is equation number 2. So we can write from 2 here, this equation from 2. You are going to write like this. V plus u by 2 into t is going to be s here. So what are you going to do now? V plus u by 2 is equal to, okay, so what are you going to write now here? S by t. Okay, so this goes here, s by t will come. So v plus u is equal to, this 2 will again go here, 2s by t. Let us consider this is equation number 4. We just changing the terms over here, that is v plus u by 2 into t, can be written as t comes to denominator, s by t it becomes, and this 2 goes here, 2s by t. So this is equation number 4 we are going to write now. So what are you going to do here? Multiply 4 and 3. You can just multiply 3 and 4. Okay. So multiply these two equations. What are you going to get? V minus u into v plus u is equal to right hand side. Left hand side we have multiplied here. Right hand also we can multiply at into 2s by t here. Okay. So what are you going to get cancelled here? T gets cancelled. So a minus b into a plus b. A minus b into a plus b is going to be a square minus b square here. So v minus u into v plus u is going to be v square minus u square. So this is going to be 2as. So we got the third equation of motion also. Okay. So we got this as a third equation of motion. So these three equations we have got now. Okay. So now we are discussing about the fourth equation of motion and how can we derive this fourth equation of motion. Let us see here. So in this fourth equation of motion, let us imagine this is going to be the initial velocity of a body, a car is moving here. Now let us take here, this is the displacement traveled by the car in 5 seconds, let us imagine. So in 5 seconds from here to here it is moving. Then what is the meaning of that? That means that it travels only this much distance in 4 seconds. It travels only this much distance in 4 seconds. And what is this going to be? This is the displacement traveled by the body in the last, that is 5th second. Okay. So this is the displacement traveled by the body in the 5th second. So if you observe this one, if the total distance traveled by a body for 5 seconds is from here to here now, and displacement traveled by the body in 4 seconds is this much only, then this will be the displacement traveled by the body in the 5th second, that is going to be the last second. This is a general example I am taking now. Now here, if you convert this in terms of nth second, now let us imagine here we write displacement traveled in 5th second is going to be displacement traveled in 5 seconds minus displacement traveled in 4 seconds. So displacement traveled in 5th second is equal to displacement traveled in 5 seconds minus displacement traveled in 4 seconds here. Okay. So this is going to be the equation we are writing. But in terms of general condition, if you do take here, what are you going to write now? If you are going to consider the general condition, you write displacement traveled in nth second. That means let us take this is the nth second. Nth means the last second. That last second may be 5th second or 6th second or 20th second or 100th second, whatever it may be. That is in general, if you consider that is the nth second, what are you going to write now here? So displacement traveled in nth second will become displacement traveled in n seconds minus displacement traveled in n minus 1 seconds here. Because if this is 5, this is going to be 4. Then if this is n, this is going to be n minus 1. Then. So this is the finally we are writing this equation as the first equation here. So let me write this equation as the first equation here. So now separately we need to find out, for example, displacement traveled in t seconds. If you take, what are you going to get the formula, general formula? You will get ut plus half at square. Displacement traveled in t seconds means ut plus half at square. You know about this, just now we have derived here. But if, for example, if you consider displacement traveled in n seconds means what are you going to write? So you will write un plus half a n square. That is, we are just replacing t with n. We are just replacing t with n here. You are getting this equation of motion. Now, displacement traveled in n minus 1 seconds if you imagine. That is one less. This one we are finding now. This one we got Sn is equal to un plus half an square. But displacement traveled in n minus 1 seconds we are going to find out here. How are you going to find out here? Just you have to keep t as n minus 1. That's it. So instead of t, if you write n minus 1, you are getting the equation just now. So u into n minus 1 plus half a into n minus 1 whole square. You need to expand this n minus 1 whole square. Then what are we going to get? Let us see here. So u into n minus u plus half a. This is a square plus b square. B square means 1 square minus 2ab. 2 into n into 1, that is going to be 2n. Okay. So we have just expanded a minus b whole square formula. Then finally, what is the step you are going to write? So displacement traveled in n minus 1 seconds can be written as un minus u plus half an square plus half a minus half a into 2n. So half a into 2n means 2 gets cancelled. What is left here? an is left here. So I am going to write an over here. So I am going to write an over here. So this is going to be an. This is a completely equation we are getting now. So here, let us imagine this. Let us take this equation as the second one and this equation as the third one here. Okay. So this is the third equation. Let us do one thing here. What are you going to do here? Now you are substituting 2 and 3 in 1. Okay. So you are taking these two equations, substituting here because you wanted to find out nth second here. So how are you going to find out the nth second? For that, you need to do one thing. Displacement traveled in nth second is equal to, instead of Sn, you will take this one. What is that? That is going to be un plus half an square minus Sn minus 1 second means you ordered all these things. Okay. So just generate a bracket here. Then you'll write un minus u plus half an square plus half a minus an. That's it. This is going to be substitution here. After substitution, you're going to get like this. So then let us expand this one and simplify and get the final step here. So what are you going to do to get the final step? Displacement traveled in nth second is un plus half an square minus, you will write un, minus into minus is plus here, again minus into plus is minus half an square, minus into plus is again minus half a, minus into minus will become plus. So an you are getting. So what are you going to do now here? You just do one thing, minus and plus you need to cancel here. So what are the terms which to be cancelled? This is plus, this is minus. This is plus and this is minus. If you cancel this one, the finally, what are the terms which are going to be left out here? This is left out, this is left out, this is left out. Let us arrange this in a proper way so that you will get the final formula here. So you need to do one thing here. Yes, nth is equal to u. First you write an. After that you take minus half a, because these are the three terms which are left out. Why you need to write like that? So that we can get the final result as in that fashion here. So final result should be in that fashion. Displacement traveled in nth second is u plus a. If you common out, you will getting n minus half. Okay. So this is the final. This is the final equation here. Okay, students. Today we are discussing about equations of motion by using graph. How are we going to discuss equations of motion by using graph here? Okay, so we shall discuss what is the meaning of this graph. So for example, I am taking this x-axis as time graph. This is a time graph. And this is y-axis, this is going to be a velocity graph. So this is called as VT graph here. So if this is VT graph, let us take here, for example, here, a car you are considering having initial velocity 5 meters per second, and it is slowly increasing its velocity, and it has raised its velocity to 15 meters per second, let us imagine. Okay, so initial velocity is already, it is having 5 meters per second. Slowly its velocity is increasing up to 15 meters per second. Then the distance traveled by this car from here to here is s, and time taken is t here. So this situation in terms of graph, how are you going to explain? How are we going to discuss about this same concept in terms of graph here? For example, A is a point where already this car is having certain initial velocity. Let us consider this initial velocity in terms of values here. So what is the meaning of this, So it is already having u is equal to 5 meters per second. So 5 meters per second. So v is the final velocity. So car is moving from here. Starting point is this one, ending point is this one. So final velocity can be considered as 15 meters per second. So instead of drawing the graph from the origin, this is going to be the origin. So you can draw the graph like this also, but this situation is different. For example, you can draw the graph like this also. Okay. So this is the situation where initial velocity is 0. So when the car starts from 0 velocity, the graph starts from origin. But already car is having 5 meters per second initial velocity. That means origin of the car will be somewhere here, but we are drawing in the middle of the situation, that is from 5 meters per second to 15 meters per second, and that too slowly velocity is increasing from 5 to 15. So this is 5 meter initial velocity, 15 meters is the final velocity. Okay, so this is the 15 meters we have drawn here. So how can we find out now in this case? How can we discuss about the equations of motion? Let us say here. So first equation of motion we shall discuss here. The first equation of motion is, it is v is equal to u plus at. We have to derive this one. How are we going to derive this one? Let us see here. The first thing is acceleration we need to find out. So how can you find out the acceleration in this case? So acceleration is nothing but, you can find out acceleration has to be slope of the graph here. Acceleration is nothing but slope of graph. So what do you mean by slope of the graph? Acceleration is equal to change in velocity by time here. So change in velocity is considered to be this part here. If you consider the smallest, this part here from here. So what is this part going to be? Here. This part can be considered as v minus u from here to here. Okay. So let me draw this one here separately. So if you consider only this much part, that is going to be v minus u. Whereas the complete velocity is considered to be v here. Okay, so final velocity is v. And this much part in the graph which is starting from here to here, that is going to be v minus u. Okay, so we need to find out the slope of the graph. Slope, acceleration is equal to slope we can write here. And what is this slope here? Slope is considered to be tan theta. According to concept of graphs. If you want to find out acceleration, if you want to find out the slope, that is going to be tan theta. Then what is going to be tan theta here? Tan theta is nothing but opposite side BC by adjacent side AC here. This is opposite side, this is adjacent side. So if this is the condition here, what are you going to do now here? To find out the acceleration, we need to find out BC. So here, acceleration is equal to, we can write one more step here. Acceleration is nothing but BC by AC. So what is BC in this case? So this much part is nothing but, if this part is u here, so you can write like this also here. So this is u, so this is also going to be u here, okay. So this is also going to be u, and this is going to be v here. Then what is this part? That is going to be the difference here. So as it is going to be the difference, BC means what are you going to write now? So here you are going to write here, BC is nothing but this much part, that is v minus u, and AC is nothing but the time taken from here to here. So how much time it is going to take here? V minus u by t. So therefore, v minus u is equal to cross multiplication. If you do, it is going to be at. So v is equal to u plus at. Okay. So we have discussed about velocity. We have found the first equation of motion by using this graph only. Okay. So what we need to do, find out the displacement here. So we shall discuss about the second equation of motion also here. So this is the second equation of motion. Let us take S is equal to ut plus half at square. We have to derive this equation by using the same graph. But you need to understand one thing here. So to find displacement, in VT graph, in velocity time graph, we have to find area of the graph. We need to find out the area of the graph here. If you find out the area of the graph, you are getting displacement. Acceleration means you need to find out slope. Displacement means you need to find out the area of the graph. So how are you going to find out the area of the graph here? So to find out the area of the graph, so therefore displacement S is equal to area of graph. So here there are two parts in this case. First part is area of triangle plus second part is area of rectangle. Why I am writing like this? So this graph totally, if you consider, the area of this graph is this rectangle, this triangle as well as this rectangle combined together. This is going to be the total area here. So if you find out the total area, then you will getting the displacement. What is the meaning of this? You need to find out the area of the graph below the line AB. This line AB, whatever it is coming below that line, that is going to be the area of that graph. So to find out the area of that graph, first area of the triangle plus area of the rectangle. So here S is equal to area of the triangle. What is that area of the triangle? That is triangle ABC, you can write first. So it is area of triangle ABC plus area of rectangle. So rectangle, area of a triangle, you can write here only, area of a triangle is going to be ABC, triangle ABC plus area of a rectangle. What is this rectangle going to be? ACDE. This is a rectangle ACDE. So how are you going to find out the area of a triangle? Area of a triangle is nothing but half into base into height plus area of a rectangle is nothing but length into breadth here. So these two parts separately if you observe. So displacement is equal to half. Here base of this triangle is going to be, base of the triangle is going to be the time here. So what is going to be the height here in this case? You can write height as V minus U. So half into base into height. Height can be written as V minus U. Okay, this is separate part you can consider. Length into breadth. Length you can consider T and breadth you can consider, for that it is U here. So you all know A is equal to V minus U by T. So can you replace V minus U with AT? Yes, we can do that one. So you can replace V minus U with AT. So what are you going to do now here? The final step is S is equal to half into T. V minus U can be written as A into T separately, plus you can write this as TU or UT, whatever it may be. So the final step you are going to get is the equation. This implies that it is going to be S is equal to UT plus half AT square. That's it. So we are getting the same equation by using the graph also. I think it is clear. So this is by using graph also. Okay. So this is the fourth equation of motion we are deriving with the same graph which is discussed in the previous case. So we have derived the first equation of motion, second equation of motion. Now we need to discuss the third equation of motion. The same way what we have discussed in the second equation of motion, the same concept we are discussing here also, but slightly the method is different here. So we need to find out displacement. Yes. So displacement is nothing but area of trapezium. This is going to be the trapezium. What is this trapezium? So we can write here area of the trapezium. A, B, D, E. So A, B, D, E, A. So you can consider this is computed at closed trapezium here. So what is the formula for trapezium? We shall find out here. Displacement is equal to area of the trapezium. So formula is half into sum of parallel sides into distance between them. So what is the formula here? To find out the area of a trapezium, half into sum of the parallel sides. This is one parallel side, this is one parallel side. So sum of the parallel sides and the distance between them. That is going to be the area of the trapezium. So this is according to mensuration concept in mathematics. Area of the trapezium is nothing but half into sum of the parallel sides into distance between them. That's it. You'll get the answer. It's very simple. So S is going to be half. Sum of the parallel sides means what are you going to write here? It is parallel side is AB plus again BD. So AB plus BD and what is the distance between them? Distance between them you can consider it as AC. So S is equal to half. AB means you can write U plus BD means completely you can take it as V from there. Then what is AC? So AC can be written as T here. So now, but you know that A is equal to V minus U by T. That means T is equal to V minus U by A. So this is the formula for T here. We have got from general formula of acceleration. This T, if you substitute here, you will get the final equation, that is S is equal to half into U plus V or V plus U, doesn't matter. I am writing in a particular order so that we can simplify it easily. So instead of writing U plus V, I am writing V plus U. T can be written as V minus U by A. That's it. So displacement is equal to half. V plus U into V minus U, that is A plus B into A minus B, is V square minus U square will get, in the denominator getting A. So now V square minus U square, you keep it in the numerator. This 2A you can pass out here, you can transfer here. The finally you are getting 2A. Yes, that's it. So this is the final equation here. So we have derived the third equation of motion also by using the graph. I think you understood here. This is slightly different is there. If you want to find out the second equation of motion, you have to find out the area of triangle separately, area of the rectangle separately. But when you are deriving the third equation of motion, you are doing something different. What is that? Instead of finding these two separately, you will find out the total area of the trapezium in this case. Then you will get the answer very simple. Thank you.